Good day everyone, welcome to our continuation on the topic differentiation. Today we will be discussing implicit differentiation. Our very first question is from 1997 and it states that if 2x squared minus 5y squared equals to 6xy, find the y over the s. Now when we solve implicit differentiation, if you have a component that is purely s, we differentiate it manually. Then if we have a component that is purely y, we differentiate it as a chain rule. That's d over ds of that function, that's that part that is y, will be equals to d over dy of that part times dy over dx. That is, we are going to be differentiating it with respect to y and adding dy over dx. Then if we have a component that is a mixture of s and y, we are going to be doing it as we solve product rule normally. We differentiate just s, treating y as a constant. Then we differentiate y, treating s as a constant. Then add dy over dx to it. Let me try and explain that using this example. Now the very first component of our equation is 2s squared. Since it's purely s, we are going to be differentiating it directly. That's d over ds of 2s squared is equals to 4s. Now the next component is 5y squared. Like I said earlier, I will be differentiating it as a chain. That d over dy of 5y squared times dy over dx. Simply put, we are differentiating it with respect to y and multiplying by dy over dx. Doing so, 5y squared differentiating with respect to y will be equals to 10y times dy over dx, which is 10y dy over dx. Then our other component, our 6sy, will be differentiating y, then adding dy over dx, treating 6s as a constant. Then we differentiate s, treating y as a constant. So doing so, d over dx of 6sy. Now firstly, we are going to be differentiating just the y aspect. Differentiating y and treating 6s as a constant to give us 6s dy over dx, because whenever we differentiate y, we add dy over dx, plus differentiating s and treating 6y as a constant will give us 6y, which breaks down to 6s dy over dx plus 6y. Now adding everything together, it becomes 2s squared minus 5y squared equals to 6sy. Differentiate to become 4s minus 10y dy over dx equals to 6s dy over dx plus 6y. At this point, we are going to be collecting like terms. That's, we bring all our y dy over dx components to one side of our equation and the other component to the other side. Doing so, 4s minus 6y will be equals to 6s dy over dx plus 10y dy over dx. At this point, we are going to be factorizing out dy over dx in our right hand side. Doing so, it becomes 4s minus 6y will be equals to dy over dx in bracket 6s plus 10y. At this point, we are going to be making dy over dx our set formula. We are going to be making dy over dx stand alone by dividing both sides by 6s plus 10. Dividing both sides by 6s plus 10, 4s minus 6y divided by 6s plus 10y will be equals to dy over dx. Factorizing our left hand side, in our numerator 2 is common and in our denominator 2 is also common. So it becomes 2 in bracket 2s minus 3y divided by 2 in bracket 3s plus 5y will be equals to dy over dx. The 2 is going to cancel out and we are left with 2s minus 3y divided by 3s plus 5y is equals to dy over dx. So therefore, dy over dx is equals to 2s minus 3y divided by 3s plus 5y. We have another example from 2005 that states that differentiate with respect to s, y squared plus s squared minus 3sy is equals to 4. As usual, we are going to be differentiating each of the constituents individually. We are starting with y squared, then we are going to be differentiating s squared, then 3sy, then 4. Starting with y squared is differentiated as chain. it's going to give us d over ds of y square, that is the derivative of y square, will be equals to d over ds of y square times dy over ds. That is, we are going to be differentiating y square. Normally, it should give us 2y, then dy over ds. Now for the s square, we are differentiating it directly. So d over ds of s square will be equals to 2s. The next part of our equation is the 3sy. 3sy is differentiated as product. Doing so, d over ds of 3sy will be equals to 3s dy over ds plus 3y ds over ds, which will be equals to 3s dy over ds plus 3y. 4 is a constant, hence it is differentiated as 0, because whenever we differentiate a constant, we will get 0. So combining everything together, y squared plus 2sy minus 3sy equals to 4 differentiated becomes 2y dy over ds plus 2s minus, in brackets, 3s dy over ds plus 3y equals to 0. Our next call of action is to expand our bracket. Doing so, our equation becomes 2y dy over ds plus 2s minus 3s dy over ds minus 3y is equals to 0. Next, we are going to be collecting like terms. That's taking all our dy over ds component to one side and the rest part to the other side. Doing so, our equation becomes 2y dy over ds minus 3s dy over ds will be equals to 3y minus 2s. Now we are going to be factoring out dy over ds in our left hand side to make our equation become dy over ds in bracket 2y minus 3s will be equals to 3y minus 2s. At this point, we are going to be dividing both sides by 2y minus 3s to make dy over ds to be left on its own. Doing so, dividing both sides by 2y minus 3s, dy over ds will be equals to 3y minus 2s divided by 2y minus 3s. Our next question is from NECO. It states that find dy over ds if 4s to the power of 4 plus y cube is equals to 12s square y. And as we've been doing, we'll be differentiating each of the constituents individually. They at the end will compile everything together. Now differentiating 4s to the power of 4, since it's s, is going to be differentiated directly. So dy over the s of 4s to the power of 4 will be equals to, differentiating 4s to the power of 4 is to be equals to 16s raised to the power of 3. Now the next constituent is y cube. Now y cube, since it's y, to be differentiated as shown. So d over ds of y cube will be equals to d over dy of y cube times dy over ds, which will be equals to 3y square dy over ds. That we differentiated y with respect to y and we added dy over ds. Now the next constituent is 12s square y, and we'll be differentiating it as what? Product. So d over ds of 12s square y will be equals to 12s squared dy over ds plus 12y ds of s square, which will now break down to be equals to 12s squared dy over ds plus 24sy. Compiling everything together, 4s to the power of 4 plus y cube equals to 12s squared y differentiates to become 16s cubed plus 3y squared dy over ds equals to 12s squared dy over ds plus 24sy. At this point, we are going to be collecting our like term. That will take all dy over ds component to be in one side and the rest part of the equation on the other side. Collecting like terms, it becomes 3y squared dy over ds minus 12s squared dy over ds will be equals to 24sy minus 16s cubed. Now factoring out dy over dx in our left hand side, our equation becomes dy over dx in bracket 3y square minus 12x square will be equals to 24sy minus 16x to the power of 3. Now we are going to be dividing both sides by 3y square minus 12x square. Doing so, dy over dx will be equals to 24sy minus 16x cubed divided by 3y square minus 12x square. Our next question is also from NECO. It states that find dy over the s of the function 2x cubed y square minus 3sy square equals to 4. And as usual, we'll be differentiating each component individually, then adding everything together to get our final result. Differentiating 2x cubed y square, since it's a combination of s and y, we are going to be differentiating it as what? Product. So d over the s of 2x cubed y square will be equals to 2x cubed, then differentiating the y component, d over the s of y square plus 2y square, then d over the s of s cubed. Note that d over the s of y square is d over the s of y square times dy over the s, which is 2y dy over dx. Now combining everything together, d over the s of 2x cubed y square will be equals to 2x cubed times 2y dy over the s times 3s square. Adding our right hand side, it becomes 4s cubed y dy over the s plus 6s square y square. Next, we are going to be differentiating 3s y square. Following the same pattern, d over the s of 3s square y square will be equals to 3s in bracket d over the s of y square plus 3y square ds over ds, which will be equals to 3s times 2y dy over the s plus 3y square. Simplifying further, it will be equals to 6sy dy over the s plus 3y square. Now adding everything together, 3s cubed y square minus 3sy square equals to 4 differentiated becomes 4s cubed y dy over the s plus 6s square y square minus in bracket 6sy dy over the s plus 3y square, which will be equals to 0. Now expanding our bracket, our equation becomes 4s cubed y dy over the s plus 6s square y square minus 6sy dy over the s minus 3y square be equals to 0. Now collecting like terms, that's taking all our dy over the s component to our left hand side and the rest part of our equation to our right hand side, it becomes 4s cubed y dy over the s minus 6sy dy over the s will be equals to 3y square minus 6s square y square. Factorizing our left hand side, that's bringing the dy over the s component out, dy over the s in bracket 4s cubed y minus 6sy will be equals to 3y square minus 6s square y square. At this point, we are going to be dividing both sides by 4s cubed y minus 6sy so that we can have dy over the s. Doing so, dy over the s will be equals to 3y square minus 6s square y square divided by 4s cubed y minus 6sy. Our final example states that find dy over the s if Roman figure 1 cos s is equals to sin y and Roman figure 2 sy is equals to log y divided by s. For Roman figure 1, cos s equals to sin y. So what we do is that when we differentiate the component that has s, we differentiate it normally, and when we differentiate the component that has y, we add dy over the s. So basically, d over the s of cos s is equals to d over the s of sin y. So differentiating, d over the s of cos s will be minus sin s equals to d over the s of sin y will be cos y dy over the s because it has y in it. So dividing both sides by cos y, it becomes minus sine s divided by cos y is equals to dy over the s, or dy over the s is equals to minus sine s divided by cos y. Now for the part 2, sy is equals to log y divided by s. The very first thing we are going to do is to separate our log, and we know that log y divided by s is similar or is the same as log y minus log s. So therefore sy is equals to log y minus log s. So applying the same principle, to differentiate sy, we differentiate the s individually. Applying the same principle, differentiating sy will be s dy over the s plus y, that's if we differentiate it as a product, equals to 1 over y dy over the s minus 1 over s. The derivative of log y will be 1 over y dy over the s minus 1 will differentiate log s to be 1 over s. At this point, I'm going to be collecting like terms. That's take all our component that has dy over the s to our left hand side. Doing so, our equation becomes s dy over the s minus 1 over y dy over the s will be equals to minus in brackets y plus 1 over s. Factorizing our left hand side, it becomes s minus 1 over s in bracket dy over the s will be equals to minus in bracket y plus 1 over s. At this point, I'm going to be dividing both sides by At this point, we are going to be simplifying our left hand side. That's simplifying the fraction of our left hand side and our right hand side. Doing so, our left hand side becomes sy minus 1 divided by y in bracket dy over the s will be equals to minus in bracket 1 plus sy divided by s. Now dividing both sides by sy minus 1 divided by y to make dy over the s stand alone, dy over the s will be equals to minus in bracket 1 plus sy divided by s divided by sy minus 1 divided by y. Changing our division to multiplication, that's we are going to be carrying our denominator of our fraction to the numerator. It becomes dy over the s will be equals to minus in bracket 1 plus sy divided by s times in bracket y divided by sy minus 1. And our final answer will be dy over the s is equals to y in bracket 1 plus sy divided by s in bracket sy minus 1. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copy in any bookshop, or if you are interested in the soft copy, you can get it at the website at the bottom of your screen. Thank you.